We'll start in 1 minute. Today we'll cover part 1 of section 2.6 on solving compound inequalities. First, a definition. Okay, a compound inequality is made up of two inequalities connected by the word and or the word or. To begin with, compound inequalities made up of two inequalities connected by the word and will be covered. So consider the following example. As far as I could tell, officer, the burglar was taller than 70 inches and shorter than 74 inches. So we could say, well, if the burglar was taller than 70 inches and shorter than 74 inches, then the height, well, 70 inches would have to be less than the height. And at the same time, the height would have to be less than 74 inches. So this is sort of a rough way to write the compound inequality. If two inequalities are connected by the word and, then only numbers that satisfy both conditions are included. Okay, the next sentence. Two inequalities connected by the word and mean that the intersection or overlap of the two inequalities consist of the numbers that satisfy both conditions. With interval notation, we use this symbol for the intersection. It sort of looks like an upside down U, but another descriptor for this is a cap. But we use this for intersection or overlap. Okay, so for the inequality that was described above, this one up here, the burglar was taller than 70 inches and shorter than 74 inches. We'll write the algebraic notation and the interval notation for the compound inequality. So let's assign the letter H be the height of the burglar. Let H be the height. Of the burglar. Well, the height was taller than 70 inches. So we could start by saying h is greater than 70 and shorter than 74. So h is greater than 70 and h is less than 74. So remember that the word and means that the height has to satisfy two conditions at the same time. One is h is greater than 70. The other condition is h is less than 74. But we can do better than this, as you've already seen. Since h is greater than 70, that means 70 is less than h. So 70 is less than h. And at the same time, h is less than 74. So this is the desired algebraic notation for that compound inequality, algebraic notation. So the algebraic notation, we always use the variable. Okay, for the interval notation, well, remember the interval notation for h is greater than 70? So I'll circle this and put an arrow over here. The interval notation for h greater than 70 is parenthesis 70 comma infinity. The interval notation for h is less than 74. I'll put that over here. If h is less than 74, then negative infinity, parenthesis negative infinity, comma 74. And the word and, we use the intersection symbol. So the cap. But in this case, the interval notation can be written more compactly. The intersection of those two sets of numbers can be written this way, parenthesis 70, comma 74. So for this particular example, this is the interval notation that we want for that set of numbers, interval notation. Okay, we'll do another example. It's a variation of the one above. This one says the burglar was at least 70 inches tall and no taller than 74 inches. So if the burglar was at least 70 inches, then 70 inches is one of the possible heights. So we could say 70 is less than or equal to the height, and no taller than 74 inches. That implies that the burglar could be as tall as 74 inches. So on this one, we would write 70 is less than or equal to the height h, and at the same time, the height is less than or equal to 74. So this is the algebraic notation, and then the interval notation, we would put bracket 70, comma 74 bracket. Okay, the one on the left is algebraic notation. And the one on the right is the interval notation. They both mean the same thing. And once again, I'll remind you frequently, in the algebraic notation, the algebraic variable is always involved. In the interval notation, we don't use the variable. We just use grouping symbols, parentheses, or brackets, and the numbers. Okay, let's look at the next page. We see a warning at the top. Warning, a compound inequality made up of two inequalities connected by the word and may be impossible. So the following example illustrates the foregoing remark. The burglar was shorter than 70 inches and taller than 74 inches. Well, that's impossible. It's possible to say things that are completely false. So this could never happen. A burglar could not be both shorter than 70 inches and taller than 74 inches at the same time. So this cannot be possible. This cannot occur. All right. Well, we have a way to deal with such situations in algebra. So in the next statement, if two sets of numbers do not overlap, then the intersection of the two sets is empty. So in this case, the intersection is the empty set. And the mathematical symbol for the empty set, it's the letter or the number O, or number 0, I mean, with a slash through it. Okay, so going back up here, the empty set, the set that has no elements, and then the mathematical symbol, the letter or the number 0 with a slash, empty set. Okay, let's look at some examples. So the directions are write the following compound inequalities using algebraic notation and interval notation for these basic examples. I'll do a little bit more to get the idea of an overlap. So for a graphical illustration, I'll use 3 number lines. So for the top one, I'll graph x is greater than 3. And for the bottom one, I'll graph x is less than 5. And then on the bottom one, we'll graph the overlap. So the overlap is the informal way to describe the intersection. Okay, so here's the number 3 and the number 5. I'll plot the numbers 3 and 5 on all three number lines. If x is greater than 3, that's what we're considering first. If x is greater than 3, then we put a parenthesis at 3 opening to the right, and then we shade everything to the right of that. And the next one, the second one, let's graph x is less than 5. So if x is less than 5, then we put a parenthesis at 5 opening to the left, and then we shade everything to the left going to negative infinity. Okay, and you can see where the top two lines overlap, or where they intersect. They intersect at the numbers between 3 and 5. This is the intersection. Okay, so the algebraic notation, what's the algebraic notation for the x is greater than 3 and x is less than 5? You can type that in if you know what the answer is. Okay, well, think of where the final x number has to be. It has to be between 3 and 5. So if x is in this part of the number line, then the algebraic notation is 3 is less than x, and at the same time, x is less than 5. So this is what we want for the algebraic notation. And what about the interval notation? Yeah, the interval notation, we just write left parenthesis 3, comma 5, right parenthesis. So this is the interval notation. There's another way to write the interval notation that means the same thing as this set of numbers, 3, comma 5 in parentheses. We could write, well, x greater than 3, we could write parenthesis 3, comma infinity, and then the intersection symbol, and then x is less than 5, that's negative infinity, comma 5. This is also a valid interval notation, but it should be written more simply because the overlap is just from 3 to 5. Okay, let's try the next example. This one, x is greater than or equal to negative 4, and x is less than 6. Okay, so the word and, That means a number x has to satisfy both conditions at the same time. So x has to be greater than or equal to -4, and x has to be less than 6. If it helps to graph each of the sets separately and then look for the overlap, that's a perfectly fine way to do it. Or you can just think about what we're looking at here. X is greater than or equal to -4, and x is less than 6. So we can graph this all at once. X is greater than or equal to -4, I mean, and x is less than 6. So graphically, that's what the set looks like. And the algebraic notation, hey, type in the algebraic notation for this one. So I don't know about you, but the graph helps me see what to do. If x is in this set, then -4 is as small as x can be. So -4 is less than or equal to x, and x is strictly less than 6. So x could be 5.9999 and so on, but it never actually reaches 6. And then the interval notation, once again, if you graph the solution set, to me, that helps me know what the interval notation is. I just put a bracket, -4, 6, parenthesis, for the interval notation. Okay, the next one. X is greater than 0 and x is less than or equal to 10. So if it helps to graph, go ahead and graph. Plot the numbers 0 and 10. And remember that and means x must satisfy two conditions. In one case, x is greater than 0, and x must be less than or equal to 10. So we can sketch a graph of the solution set, a parenthesis at 0 and a bracket at 10. Okay, type in the algebraic notation for this. And then you can type in the interval notation. Well, the keyboard doesn't have a less than or equal to symbol on it. So anyway, algebraic notation, 0 is less than x, which is less than or equal to 10. And then the interval notation, this you could type in. This is parenthesis 0, 10 bracket. Okay, each of those three representations Each of those represents the same set of numbers, all of the numbers between 0 and 10, excluding 0, but including 10. Okay, let's look at a few more examples. Okay, this one, x is greater than or equal to -5 and x is less than or equal to 7. Let's go ahead and graph this. Plot the numbers -5 and 7. So x must satisfy two conditions at the same time. X is greater than or equal to -5 and x is less than or equal to 7. So graphically, x has to be at -5 and to the right, and at the same time, x has to be at 7 and to the left. So the numbers are between -5 and 7, but they include -5 and 7. And the algebraic notation. -5 is less than or equal to x, and x is less than or equal to 7. And the interval notation. So this time we put a bracket, -5, 7 bracket. So each one of those represents the same set of numbers, either graphically or algebraic notation or interval notation. Okay, so we've covered the pretty straightforward ones. Now we're going to get some that are a little trickier. So this next one, x is greater than or equal to 2 and x is greater than or equal to 4. So the word and means that x has to satisfy both conditions. So what's this going to be? For this one, let's do 3 number lines. One for x is greater than or equal to 2. The other one for x is greater than or equal to 4. Since the word and is used, we want to find the overlap or the intersection. Here's the one on the top. X is greater than or equal to 2. So at 2, and then we shade everything to the right, going all the way to -infinity. And then the next one, x is greater than or equal to 4. We start at 4 and shade everything to the right. The intersection, where is the overlap? What's that?
At 4?
Is that the only place where they overlap at 4? So,
Past 4 on both lines.
what's that?
It goes past 4 on both lines.
Yeah. So the intersection or the overlap are just the numbers from 4, including 4, and to the right. That set of numbers is in both sets. So the overlap is from 4, including 4, to infinity. Okay, so the bottom graph is the intersection. So the intersection is the same as x is greater than or equal to 4. X is greater than or equal to 4 is in both sets. And then the interval notation is bracket 4, comma, infinity. Okay, the next example, x is less than 1 and x is less than 8. So let's do the 3 graphs again and then look at the overlap or the intersection. Okay, the top one will be x is less than 1. So if x is less than 1, it's parenthesis at 1 and shade to the left, all the way to negative infinity. X is less than 8. So that's a parenthesis at 8 and shade everything to the left. And what's the overlap? In other words, what's the part of the number line that is in both sets? From negative infinity to 1. Yeah, that's the overlap. So the overlap is from negative infinity to 1. That's the same as x is less than 1, which is the algebraic notation for the solution. Okay, algebraic notation, x is less than 1, and the interval notation negative, I should say, parenthesis, negative infinity, comma, 1 parenthesis. Okay, the next one, I'll give you a few seconds to figure this one out. X is less than or equal to 3, and x is greater than 5. Somebody say something?
I know the answer.
You don't know the answer?
Oh, no, I do. Do you just want me to say it?
Can you talk about it?
Do you just want me to say the answer?
What do you say?
you want him to say the answer?
Yeah, say the answer.
It's an empty set.
Okay. Does anybody online know what the solution is? Okay, there's an answer, empty set. Yep, that's correct. Let's go through the 3-number line approach. Hey, the top one, x is less than or equal to 3. So that's from 3 and to the left. And then the middle one will be x is greater than 5. And we can see there's no overlap. So the overlap is a empty number line. So the empty set. The two sets do not overlap. Okay, watch out for those tricky ones. They're not too hard if you just pay close attention. Okay, the next page. So here we have a little bit more algebra to do. So solve the following compound inequalities and write the solutions in algebraic and integral notations. So the first one, negative 2x is less than or equal to 12, and 3x plus 6 is less than negative 3. Okay, so what we need to do is solve each of the two inequalities for x, and then do something like what we did on the previous several examples. So this first one, negative 2x is less than or equal to 12. What do we get when we solve this one for x? Yeah, if we divide both sides by negative 2, whenever we divide both sides of an inequality by a negative, we have to switch the inequality to its opposite. So we change this inequality from less than or equal to greater than or equal. And so this becomes x is greater than or equal to negative 6. And then the other one, start by subtracting 6 from both sides. So we get 3x is less than negative 9. Then divide both sides by 3, x is less than negative 3. Okay, then we want to write the algebraic and integral notations. So depending on how much detail you need to go into, if we plot the numbers negative 6 and negative 3, if x is greater than or equal to negative 6, it's from negative 6 and to the right, and at the same time x is less than negative 3. So put a parenthesis at negative 3. Okay, so the overlap is from -6 to -3. We include -6, but we exclude -3. Okay, so the algebraic notation. Algebraic notation, -6 is less than or equal to x, which is less than -3. And then the interval notation, bracket -6, comma, -3, parenthesis. Okay, the next one. X plus 5 is greater than -3, and -2x minus 5 is less than or equal to 1. So solve each side for x. If x plus 5 is greater than -3, when we subtract 5, we get x is greater than -8. And if -2x minus 5 is less than or equal to 1, start by adding 5 to both sides. So we get -2x is less than or equal to +6. And then x is greater than -8. And this time we divide both sides by -2. So -2x divided by -2 is +1x. 6 divided by -2 is -3. But since we divided both sides by a negative, we have to switch the inequality from less than or equal to greater than or equal. Okay, so what is the intersection of those two sets of numbers? What's the algebraic notation? So does anybody online know? Let's try the three number line approach. So -8 is to the left of -3. So if x is greater than -8, it's from -8 to +infinity. This is x greater than -8. If x is greater than or equal to -3, then it's from -3 including -3 and to the right towards +infinity. And what's the overlap? Yeah, from -3 and to the right. So x is greater than or equal to -3 is the intersection. So that is the algebraic notation this time. X is greater than or equal to -3. And then the interval notation. Bracket -3, comma, infinity. Okay, the next one. 3x minus 2 is less than 4, and -2x plus 10 is less than 1. So we'll solve each of those for x. First, on the left, add 2 to both sides, so we get 3x is less than 6. And on the next one, subtract 11 from both sides, so -2x is less than -10. On the left, divide both sides by 3, and we get x is less than +2. And on the right, we divide both sides by -2, and we get x is greater than 5. Okay, so what set of numbers satisfy that statement? X has to be less than 2, and it has to be greater than 5. Well, it can't happen. So this is the empty set again. No number can be less than 2 and greater than 5 at the same time. Hey, are there any questions? Does this seem pretty simple, pretty straightforward? It is pretty straightforward. You just want to make sure you don't overlook something. Yeah, we'll go ahead and get started in the next part, which we will also cover tomorrow. Tomorrow we'll do Chapter 2, Section 6, Part 2. But we have a couple of minutes. We can get started on this. And now we're going to consider compound inequalities made up of two inequalities connected by the word or. So here's an example. Either I will accept an offer to work at Google at an annual salary over $100,000, or I will accept an offer to work at Facebook at an annual salary under $90,000. So if my salary, well, I'm choosing between working at Google or Facebook. So my salary will be one of two things. My salary will be greater than $100,000. I'll just write salary greater than 100,000, or the salary will be less than 90,000. Okay, the two inequalities are connected by the word or if the two inequalities are connected by the word or, then numbers that satisfy either condition are included. Okay, that's as far as we'll go today. We'll continue from here tomorrow. So go ahead and sign in for attendance. First name followed by last initial. Carter Hill. Nicholas. Calvin Hines? No. See, Melissa Jones. Anthony Cole. All right, thank you.
Have a nice rest of the day.
See you.